My name, Charles Anthony Dinarello, is an Italian name. My whole family is from Italy. The Dinarello family from Sicily, but my mother's name, family, is from the Abruzzo. I was born in the United States on April 22nd, 1943, in the middle of World War II. On the day I was born, the Jews of the Warsaw Ghetto, knowing that they were being deported to death camps, started to fight back and did so for 31 heroic days. This image has never left me. In high school, chemistry was my favorite subject. I did not like sports very much, but rather I liked classical music. My mother wanted me to be an opera singer, and I took voice and piano lessons. My father told me to stay in chemistry because he said that the life of classical musicians can border on poverty. I love classical music, and in fact, I sang in the chorus of the Boston Symphony Orchestra for many years. I decided to go to medical school and was accepted at Yale University. Yale Medical School requires a thesis for the MD degree. I was very fortunate to have Phyllis Bodell and Elisha Atkins as my mentors. They worked in fever, and so the topic of my thesis was fever. Interest in the pathogenesis of fever goes back more than 5,000 years, and history is full of countless explanations for fever. I was 22 years old and loved what I was doing, learning how to be a physician and studying fever. The title of my thesis was The Role of the Liver in Fever, and I published my first paper in 1968. In 1969, I graduated from medical school and went to Boston for my clinical training at the Massachusetts General Hospital. Then I went to Bethesda, Maryland, and the National Institutes of Health. At the NIH, I returned to research on fever, and I was very fortunate to have my mentor, Sheldon Wolf, a giant in fever and inflammation. Without Shelley, I would not be here today to talk to you about my career in science. I wanted to take the next frontier in fever. The challenge was to purify the body's own fever-inducing molecule from human cells. There was growing evidence that the body produced its own fever molecule to account for the fevers that occurred in the absence of infection. But there was opposition to this hypothesis, and many published that fever was still caused by bacterial products, and that bacterial products attached to human proteins and cause fever. Purifying the endogenous fever-producing molecule was a daunting task. It took almost 6 years with many failures. We called it leukocyte pyrogen from the Greek word fever or heat. It was very potent and produced fever in rabbits at 10 nanograms per kilogram. It was 1977, and many did not believe that a pure protein could cause fever at such low concentrations. Many said that Dinarello's leukocyte pyrogen was contaminated with bacterial products. But we were certain that our pyrogen was free of bacterial products. Then we realized that leukocyte pyrogen did a lot more than cause fever. It caused local and systemic inflammation and stimulated the immune system. It was now 1979, and the endogenous fever-producing molecule was named interleukin-1. The next step was bold. We wanted to isolate the gene for interleukin-1. It was the very beginning of molecular biology. Human growth hormone was the first gene isolated and used to produce recombinant human growth hormone. On February 1st, 1982, I had made my first preparation of RNA from human blood monocytes. In those days, there was no PCR. There were no kits. There were no companies selling reagents. We had to make almost all the reagents ourselves. In June 1984, after 2.5 years, we succeeded and interleukin-1 became the 4th human gene cloned. We submitted our paper to Nature, and it was promptly rejected. I often tell my students that when your paper is rejected by a prestigious journal, it means your work was correct. There was joy for me personally when I injected recombinant human interleukin-1 beta into rabbits, and it caused fever at exactly 10 nanograms per kilogram. Recombinant interleukin-1 beta also caused fever in humans at 10 nanograms per kilogram. This was my vindication for all the years of criticism since 1977. What happened next? IL-1 beta was far too inflammatory to be used to stimulate the immune system. We therefore started studies to how to block IL-1. Antibodies to IL-1 beta, receptor antagonists, and soluble receptors were each developed to treat inflammatory diseases. There are now 3 approved injectables to reduce IL-1 beta in humans, and studies are now underway to use a pill to block IL-1 beta. There are many, many people to acknowledge. My collaborators in the cloning project and our collaborators in the development of drugs to reduce IL-1 in inflammatory diseases. In accepting the Tang Prize, I thank all who have contributed to the understanding of the role of interleukin-1 in both health and disease. Thank you.